Hello, everybody. Even though I'm not here in person, I can still guide you through learning mathematics. Today, you're going to be playing more with, digging deeper into polar curves. There's some beautiful polar curves animating. And you're practicing two things. You're going to be practicing graphing them, which is kind of like the main technique that you need to be able to do. But more importantly than that, you'll also practice thinking about why things make sense. Like, it's more than just pretty pictures and like, oh my gosh, we can make so many like petals. It's like, why are these things happening? So before we do any of that, let's do the warm-up. If you didn't get a warm-up, go ahead and grab one by the front. The warm-up looks like this. Go ahead in just a second and stop the video. Try to do number one together. Talk about number two. Number two, I'm trying to trick you. Well, in fifth block, or no, you are fifth block. In seventh block, some groups looked at it and they were like, we don't know what to do. And like, yes, that is my goal, is you're not supposed to know how to jump directly to the answer. So think about what things could you try to start making sense of the new curve, or make a guess and then check your guess. Okay, whoever's leading the group in the video, pause the video right now. If you're watching on different devices, stop watching on different devices. Put one person in charge. I want you to move together as a group. Okay, pause the video. 3, 2, 1. Pause the video. Pause. Okay, we're going to debrief the warm-up now. So this way of notating it is a little bit confusing. The first number is the distance, and the second number is the direction. In seventh block, some students were like, oh, a distance of 2, and they like merrily started moving a distance of 2 in some direction. But the whole point of this is you don't know which direction to move a distance in until you look at the second number. So the second number, pi over 4, so that means I'm facing in this direction, and I'm going to move a distance of 2 in that direction, which takes me to about here. So that's point A. The most important one of these to understand is, how do you think about negative distance? So the direction is still pi over 4. It's still pointed in that same direction. But now instead of moving 2 in the direction I'm pointed, I'm going to move 2 in the opposite direction. Keeping that in mind is going to clarify a lot of confusing phenomena today. So then part C is, you guys are all pretty good at this. So if pi over 4 is wrapping this direction, negative pi over 4 is the opposite direction, and I move 2 in that direction. So there's A, B, and C. Okay, so let's think through this one. This is the graph of r equals theta, and you could confirm that that makes sense by plugging in some points. For example, let's plug in theta equals 0. That's pointed this way. If theta equals 0, r is 0, which would put me right at the origin. So if you wanted to start making sense of this, you could do a similar thing. Let's plug in theta equals 0. When theta equals 0, r equals 2. And let's just go ahead and start plotting it. So when I'm facing to the right, I move 2 units out. So it's like I'm kind of starting over here. You could continue to plug in points. Seventh block was like, hey, it's like, plus 2 is like a translation. And some groups, in fact, immediately guessed, I'll just take my spiral and I'll like translate it up by 2 units. But remember, it's good that you're trying to make connections, but here, if I had like y equals, let's say, x squared plus 2, the reason this is a vertical translation is because the thing I'm adding 2 to here is the thing that's going to result in a y coordinate. It's on the outside of my x squared. So like this part is going to generate the parabola, and then after I have the parabola, I'm going to shift all the y coordinates up by 2. So here you'll notice, what am I shifting up by 2? There aren't any x's or y's. And so seventh block was like, oh my gosh, I'm expanding the radius by 2. But like, what does that mean to expand the radius by 2? Does that mean I'm moving it right? Does that mean I'm moving it up? Go ahead, agree with your neighbors right now. What does it mean to translate the radius by 2? Rather than just tell you, let's look at it. Let's test your conjecture. So here, and I'm also going to show you how you can use Desmos to graph polar curves. So in Desmos, if you just use r and you use theta, you can get theta by literally typing the word theta. By the way, don't get out Desmos right now. Just watch this, and you can do Desmos later. So this is r equals theta with a k value of 0. So this is like what is on your sheet of paper right now. It's this spiral. So watch what happens as we increase k. Oh, so here I'm going out, 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 out. So you can see the initial point is moving out the way that we saw, but it's sort of like all the points are moving out. So if we ask like what is being translated when we're adding k, it's like the radius is getting larger in all directions, which sort of makes sense because theta could be any direction. So no matter what theta is, r is going to be larger than it used to be by whatever k is. So it's sort of like we're expanding out in all directions. Okay, so let's now proceed. Hold the phone. So let's now proceed to the main event of the day. Today you're going to explore a family of curves, notice some things, and then explain some things about them. So let's do an example. Let's say this is the family of curves we're looking at. You're already familiar with families of curves from rectangular coordinates. So here, let me get back out my video. So like if I said to you, like what family is y equals x squared times k, it's like it's a whole bunch of curves. So if k is 1, then it looks like this. And if k is 1/2, then it's sort of wider. And if k is -1, then it's upside down. And if k is 0, then what happens if k is 0? It's like 0 times x squared gives me just like a horizontal line. So depending on the value of k, you can get a whole bunch of different looking things. And then you might want to know, well, why is this one not a parabola? Or like why, when you multiply it by 1/2, does it get wider? So we're going to do that kind of thing, except for polar. So let's imagine, what different curves could this look like with different values of k? It's easy and fun to just like plug it into Desmos and look at this. And like I'm noticing a bunch of things. It's interesting, lots of different shapes. But I don't know if I have a lot of insight here. It's not like looking at this picture, I'm like, oh, that makes sense. When k is, like, I can't even read it because it's moving too fast. Like when k is 0.2, I see a something. So, this is nice as a starting place, but I really want us to be able to say, like, why are these things happening? So what you're going to do, I'm about to illustrate the process that you are going to go through. So if I was going to do this same thing, I'd say, okay, instead of having a slider, let's look at specific values of k. So what happens if k is -2, -1, -1/2, 0, 1/2? Go ahead, pause the video, notice a couple of things with your partners. Here are the kinds of things you could notice. What is a feature of the graph that makes you wonder, why is that happening? Or what's a connection that you see between the k value in the graph, or what's a connection you see between graphs and other graphs? Okay, now pause the video. Okay, I hope you talked about it. Here are some things that 7th block noticed. 7th block noticed that the graphs for this one and this one are the same. And the k values are the same magnitude but opposite signs. And so they thought, well, maybe it doesn't matter whether or not the k value is positive or negative, you're always going to get the same graph. So good conjecture. They noticed that these two graphs have loops. Yes, that's a very noticeable fact. And they said, well, maybe it has to do with it being a fraction. Maybe fractional things cause loops. And so that's another conjecture that you could try and figure out why, like, is that true? And more generally, we could ask, what is causing the loops? People were noticing that this is like almost but not quite a circle. This is sort of circular, but it's sort of like less of a circle than this one is. People were noticing about these 1/2 ones, it looks like the height of this loop appears to be a height of 1/2, and it's hard to tell if that's really true or it's really just a visual trick. But they were noticing that. If the k value is 1/2, this height looks like it's 1/2, and again, this highest y value here looks like it's 1/2 above 1. And so that's also kind of interesting. So in your work, you're going to practice graphing a bunch of polar curves. You're going to notice some things. Here are the things that we noticed. And then the most important thing is you're going to explain, why are those things happening? Well, okay, how in the world are you supposed to explain why these things are happening? The trick is you're going to make connections between the polar version of the graph and the rectangular version of the same graph. So notice, this is 1/2 plus sine theta. This is 1/2 plus sine x. Each part of the polar curve here corresponds to part of the rectangular curve here. So like this part right here where my mouse is, That's between angles of 0 and 90 degrees. So I know that this red part of the curve corresponds to this green part of the curve all the way around here, angles from 0 to 90. So if we could figure out like which angles correspond to the loop, that might tell us why is the loop happening. And if we know why the loop's happening, we could make a connection to this number 1/2. Like, what is it about 1/2 that makes this graph do the thing that makes that graph have a loop? So connecting the number to the rectangular graph to the polar graph, that's going to be like the gold standard for explanations. Okay, so just to be clear, what you're practicing today is like graphing polar equations by hand, because eventually on the test, you're going to need to be able to graph them by hand. So that's the first half of this. Just can you make some graphs? But then we aspire to more in this class. So the main thinking thing I want you to try and do is try and find connections between those things to understand why are things happening. All right, so you get to choose whichever family you want on the next picture. So talk over with your group. Do you want to analyze this family in question 1 or this family in question 2? They're both cool. They both do interesting things. Neither one is particularly harder than the other. It's just whatever you want to do. So decide right now. Try and decide before you actually graph anything. And then your investigation, let me show you what it looks like. The sub hopefully has passed out the papers. If the sub hasn't passed out the papers, in a second you can pause it and say, substitute. Could we please have some papers? Okay, here we go. So, my bad here. It shouldn't say y equals something as a function of theta. That should say r. But this is what the paper looks like. One side says family 2. The other side says family 1. Choose the side you want to work on. And what you're going to do is choose 3 specific equations where you choose different values for k. It's up to you what you want to choose for k. You could do 2, 3, 4. You could do -1. -2. It's a little silly to do k equals 1 because we know what that looks like. But, maybe you actually want to do 1, 2, 3 to like pick up a pattern. But the point is, once you've chosen your equation, sketch the rectangular version of the equation, sketch the polar version of the equation. Once you have all 3 of them down at the bottom, bullet points about things you're noticing. You should, I'll have the sub give you about 30, 35 minutes to do this. In which time you'll pause the video, then you'll play the video again, and I will tell you some things that you could have noticed. Then you'll have 15 minutes to try and explain them. Then there will be an exit ticket where you will individually do a couple of things, but in particular share what your group explanation was. Okay, get ready to pause it. Go ask the sub for this piece of paper. Don't use Desmos right away. Make these by hand first, and then you can check Desmos after the 35 minutes. Ready, steady, go. Pause the video. Okay, we're back, hopefully. You can, now in a second, once I'm done talking, you can open Desmos and check things out for yourself. Let's explore family 1 first. So family 1 was sine of k theta for different values of k. So let's take a look. When k is 2, I am noticing that there seem to be 4 petals here. And when k is 4, it appears that there's 1, 2, 3, 4, 5, 6, 7, 8 petals. That's interesting. So it seems like there are, first of all, it's interesting, why are petals happening at all? That's a question. It seems like the number of petals is twice the k value. Except if k equals, if k equals 3, now there's 3 petals. And if k equals 5, there's 5 petals. So a really great thing to try and explain would be, why is it that for even values of k, the petals are twice k, and for odd values of k, it's just the same as k? That's the goal. Or also explaining why petals are happening at all. An interesting separate thing would be, like, let's actually look at how the polar graph gets traced. So if I'm graphing it like one angle at a time, here's 2 theta. So it might surprise you that it's graphing in this ordering. Because you might have expected it, let's pause, you might have expected it to draw the petals in quadrant 1, and then in quadrant 2, and then in quadrant 3, and then in quadrant 4. But what's actually happening is, we draw in quadrant 1. And now when the angles are between 90 and 180 degrees, we're actually drawing over here in quadrant 4. So it might be worth thinking about why is that happening. And again, you're going to answer this question for yourself by looking at what's happening in the rectangular graph. You're going to answer it by looking at y equals 2 sine x. Whoa. What the? Oh, 2 sine 2x. Okay, hold on. Okay, so this graph right here, but in the angles between 0 and 2 pi. So like, why is it that this rectangular graph ends up making the polar graph trace in such a strange way? Okay, so that's family 1. Let's look at family 2. So family 2 was 2 minus k times theta. So let's look at a couple of values for k here. So when k is 0, I have a circle. Here's k1, 2, 3. If I'm going to go negative, I've got 0, negative 1, negative 2, negative 3. So one thing I'm noticing is that the negative and the positive versions seem to be reflections of each other. That's sort of like downward, and that's kind of upward. I'm also noticing that by the time we get to 3, there's a little loop, but there is no loop for 2 or 1. And so I'm kind of wondering why that is. Again, if you're going to explain this, the gold standard will be explain how the loop relates to the rectangular graph and explain how that relates to the k value. For group 2, I'm going to pose a more general challenge. What happens if we have a and b? So instead of 2 minus k sine theta, what happens if we have two unknowns, a and b? You will really understand what you're doing if, once you're away from Desmos, I can say, what if a is 7 and b is 9? Is there going to be a loop? If so, and is the graph going to be kind of mostly above the axis or mostly below the axis? If you can answer those kinds of questions and be able to kind of explain why, you will have understood this very clearly. Seventh block also found one more cool connection. Here we've got 2 and let's do 2 and positive 3. They were noticing here that the smallest y value it ever reaches is negative 5. And the largest and smallest x values are a little bit hard to tell what they are. But they were interested in trying to figure out, could you find the largest and smallest y values and x values just based on the number k? So that's another target you could try and explain. All right, so here on the screen for your reference are some questions you could try and answer for family 1 or for family 2. Take your notes wherever you want to, but remember that in your exit ticket, I'm going to want you individually to give me your best explanation for one of these questions. Go ahead and pause the video. Take another 15 minutes. All right, so last of all, before you put your devices away, here's the exit ticket. The sub will give it to you. I'd like you to do your best to sketch the rectangular graph of sine 4x and the polar graph of sine 4 theta. Rectangular graph, polar graph. Notice that you're going to try and do the one that wasn't the main problem your group was working on. But hopefully you'll be able to do it. And then at the bottom here, choose one of the things that you think you can explain clearly. Feel free to copy graphs or whatever else from your work. Give it a shot. The sub is hopefully giving you about 20 minutes for this because I think that's about the right amount of time. Remember, as usual with exit tickets, important that you show your own work because this is how I decide if we need to do more review. So if I look at these and everybody looks good, I'll be like, great, we don't need to do more review. We're going to go straight to the quiz. So if you're not sure how to do something, write me a little note that says, don't know how to do this thing yet. All right. I hope that you had some thoughts you were proud of today. I hope you have good weekends. I'll see you on Monday.